In the last three videos, we saw three very useful pieces of geometry for manipulating lines. We saw how to scale lines to make them longer or shorter, rotate lines by exactly 90 degrees, either clockwise or counterclockwise, and normalize a line so it has a length of exactly 1. Let's put these all together to draw a bunch of random eggs. Here's a little program that just draws lots of random eggs. They're in random orientations and at random sizes. And okay, maybe these look a little bit more like a stretched out guitar pick than an egg, but I think of them as eggs. The beautiful part about what's happening here is that I'm not using the transformation commands. I'm not using rotate and translate and scale. Instead, I'm building these eggs right in place, computing the coordinates, and then drawing a single closed Catmull-Rom curve to draw each shape. It's really a very nice way to create a huge pile of random eggs. Let's take a look at how each egg is created. Each egg is random. Now when I start, of course, I don't know what the egg is going to look like, but for the purposes of showing you how we build the egg, let's assume we already know. So this is the egg we're going to end up with, even though at the start of the process, I don't know it yet. The first thing I do is I pick a point A randomly somewhere on the screen. Then I add some random numbers to A to come up with a second point, B. And you can see that I'm going to use A as the base of the egg and B as the tip of the egg. To draw the egg, I need two more control points, which I'll call J and K. Now I know A and B because I just made them with random numbers. I know AX, AY, and BX, BY. In order to draw the curve, I of course need JX, JY, and KX, KY. I'll show you how I find those. First, I find the line from A to B. Of course, this line can have almost any length, so I normalize it. I scale it so it has length 1, and I call that line N, just shorthand for normal. Now I use our rotate trick to rotate this 90 degrees, and I find the line that is at 90 degrees to N, and I'll call that P for perpendicular. With N and P, I can build J and K. The trick is to start at A, add some of P, and add some of N. Let's start by finding the point K. I'm going to scale the line P by some amount. Let's call it K1. That just tells me how far along P I'm going to travel outward from A. Now I'll move up and to the right, parallel to the line N, and I'll do that just by taking N and multiplying it by some number. Let's say K2. The point A plus K1 times P plus K2 times N brings me right to the point K. To find the point J, we do exactly the same thing. This time I'll multiply P by a negative number. That will give me an arrow in the opposite direction of P. So let's multiply P by some value J1, which is negative. That'll give us this line. And now I'll multiply N by some number, let's call it J2. That'll give me this line. Starting at A, adding in the arrow that goes up and to the left, a scaled version of P, then adding in the arrow that goes up and to the right, a scaled version of N, brings us the point J. Well, now I have my 4 points. I just draw a closed Catmull-Rom curve through them, and I've drawn my egg. The beauty of this construction is it doesn't matter where the points A and B are. It doesn't matter how far apart they are. This framework that I'm building is completely based on the geometry of the points A and B. Everything else comes along for the ride. It's like a little piece of scaffolding that we build around the points A and B. I'll show you the code. It does exactly what we just saw. Here's the program. The basic code is all familiar to us, so I'll run through it fairly quickly. At the top, I create 8 global variables to hold the X and Y for each of my 4 control points. Setup creates the window and smooths it, and sets the background to white. Draw first calls makeEgg. MakeEgg is a little routine that does the geometry we just saw, and we'll look at that in a moment. Then I fill with a random color, and I call drawEgg. DrawEgg has nothing to it. I call begin shape, I call curve vertex for the first 4 points, I repeat the first 3 points again, as we've seen, and then I call end shape. So all the interesting stuff is happening in makeEgg. Here's makeEgg, and I said before, it does exactly what we saw in the diagram. First, I get a couple of random numbers to give me a point A somewhere on the screen. Then I add some random numbers to AX and AY, and that gives me the point B. Now I find the line from A to B, which I'm calling D. And even though this isn't a global variable, I'm giving it a capital letter because all of my other points have capital letters. dx is nothing but the differences in the x's, bx minus ax, and the same for dy. Now I find the length of d, which I'm calling len d for length of d, by calling mag with dx and dy. As we've seen, this gives us back the length of the line d. I'm about to divide by that to normalize d, so as usual, I first check to see if len d has the value 0. If len d is 0, I just set it to 1. Now I find the normalized version of d, which has coordinates norm dx and norm dy. As you can see, I just divide dx and dy by the length of d. This is now a short line in the direction of d with length 1. Here I use my standard rotation trick to rotate norm d clockwise by 90 degrees, giving me perp d. Now I have all of my geometry set up. The only thing I don't have are J1, J2, K1, and K2, which tell me how much to scale the vectors. So let's go ahead and put those in. I just picked values that I liked. J1 and K1 control the width of the egg. Bigger numbers will make the egg wider. And J2 and K2 kind of affect the blobbiness of the egg. Now I'm ready to make the points J and K. Let's look at the line for Jx first. We start with AX, we subtract something, which is in parentheses, and then we add something else, which is in parentheses. The first something is just a scaled version of perp dx. What do we scale it by? We scale it by J1 times len d. J1 is a number between 0 and 1, and len d remembers the distance from A to B. So that moves us away from A in the direction of perp d by some amount. Then I move again by adding a scaled version of norm d. In this case, I scale by J2 times len d. Kx and ky look identical to Jx and Jy except for one change. I add the scaled version of the perpendicular. That means I move down and to the right instead of up and to the left. Let's run the program. And here are all my random eggs or guitar picks or whatever the heck they are, with different sizes, different locations, different orientations, but they're all being created by the code we just saw. And as we saw, all we needed to do to make all of this work was find lines, scale them, normalize them, and rotate them by 90 degrees. This is a great technique for making frameworks for curves that you can then put anywhere you want on the screen.